So for our first question here, we have a trip consisting of 2 parts. So just like we went over yesterday, we want to break that question up into part 1, part 2, and then our totals. Because anytime a question wants to know the average velocity, we have to remember that average velocity equals the total displacement divided by the total time. Okay? So in part 1, we are told that the velocity of the bear is 20 meters per second, and that's due north, okay? And he does that for 185 meters, okay? Also north. All right, for part 2, we're told that the bear is now running 83 meters south, okay? And doing that for a time of 9.48 seconds. All right, so you can give them a mark if they have givens written down there. Okay, that'll be worth 1. So right now, can I find out my total displacement? Yeah, because I know he went 185 meters north and then 83 south. So his total displacement is 102 meters. And that'll be north. Okay, so we know that. All right, what we don't know is the total time. So we're going to have to calculate the total time by calculating first the time for part 1. All right, so time will equal d over v. Okay, that'll be 185 meters north divided by 20 meters per second. So you can give them a mark if they have that operation there. Okay, so we're up to 2 marks here, and we're getting that the time here is going to be, all right, 9.25 seconds. All right, so they can have a mark now for showing me that their total time is, or show at least that they showed they added those 2 together. Okay, somewhere along the way, 9.48 plus 9.25. All right, so we're looking at 18.73 seconds. Okay, so they can have a mark for that. So we're up to 3 marks here. Okay, our next thing is that we have to calculate the average velocity. So that will be 102 meters north divided by 18.73 seconds. Okay, if they have a v equals d over t calculation in there that shows something like that, okay, they can have a mark for that, right? And we'll get our average velocity out of that. Okay, so 102 divided by our 18.73 gives us an average velocity of 5.45 meters per second. Now, if we're doing significant figures here, this would only have 2 significant figures. So I'm just going to write it as 5.4 meters per second north. Okay, now here's the thing, guys. I don't give half marks on quizzes. If they don't have units or direction on that answer, it's simply wrong. Okay, there's no half marks on that. You have to have those things. So it has to say 5.4 or 5.45, whichever, meters per second north. Okay, they must have all of that to get that 5th and final mark on there. All right, any other questions on question number 1 before I walk through number 2? I'm not literally walking through number 2, by the way. I'm doing question number 2. That's gross. Okay, all right. Okay, so for question number, well, that's not the right question number 2. Okay, let's go back to the right question number 2. Okay, so I need everybody paying attention here on this graph. Okay, before you exchange papers or anything like that, okay, but some of you have already done that because you couldn't wait 5 seconds, okay? Here's what I need you to do. Okay, on this graph, I'm just going to quickly change these units so they make a little bit more sense, okay? We'll make this in seconds. So this is a velocity versus time graph. It is showing me how fast the object is going at various points in time. So during this first part of the graph, what is the object doing? It's accelerating. Its speed is changing. Okay? Anytime the velocity of an object is changing, it's accelerating. Whether that's speeding up or slowing down, we still call that in physics an acceleration. It's either positive or negative. Okay? What is the object doing here in this second part? It's traveling at a constant speed of 60 meters per second. Okay? Then during this part here, the long diagonal line, the object is again accelerating. Okay? Now, it's accelerating which direction? Negatively, yeah. It's because we see its velocity slows from 60 to 0, and then it actually starts going backwards, okay? So it continues to accelerate negatively until it actually changes direction right here and is actually moving backwards, okay, to this point. And then it begins to accelerate forwards again until it reaches a speed of 0. So actually this thing starts at rest and ends at rest, okay? All right, in order to calculate the displacement of the object from this graph, we're going to use the formula that we used up here. We're going to use that average velocity equals displacement divided by time. Because even when an object is accelerating, as long as the acceleration is uniform, I can calculate its average velocity during that time. Okay, as long as the acceleration is uniform, that means it's steady. All right, this graph only contains uniform accelerations. If they were not uniform, they'd be curved. All right, these are all uniform. So during this first part here, the object accelerates from 0 meters per second to 60. So what's its average during that time? 30, right? Half the time it will be going faster than 30 meters per second, and half the time it will be going slower than 30. Everybody okay with that? All right, so its average velocity is 30 meters per second, and it does that for, actually, different color, for how long? Well, we changed it to seconds, but yeah, 10 seconds. All right, so can I calculate how far it goes? Yeah, I'm going to take the average velocity, which is half of this height, and multiply it by the base, which is 10 seconds. You remember this from Science 10? You always calculated the area under the line, drew all those shapes, okay? Yeah, lots of triangles and rectangles, yeah. All right, that's why you draw the triangles and rectangles. In Science 10, we go, draw the triangles and rectangles, calculate their areas, just remember that, okay? In physics, we want you to understand why that works, okay? In physics, we want you to understand why that works. Here's why it works. We just said the average velocity here is half the height, right? The velocity changed from this to this. The average velocity occurs right here. So when we go base times height divided by 2, what we're really doing is going time times average velocity, which is just a manipulation of that formula for D. Okay, so when you calculate those areas, really all you're doing is manipulating V equals D over T for D. Okay. All right, so for this first part here, then we have our 30 times 10. Okay, so this will be 300 meters. Okay, for that one. Then we have this rectangle here, which is 60 times 5, so also 300. Okay, then we have this triangle here, which is going to have a height of 60 and a base of 15. Okay, I'm not going to do that one in my head. 60 times 15 divided by 2, 450. Okay. So this one's 450, and then we'll have these two triangles here. So this triangle will be negative 20 high by 10, so that'll be 200, but divided by 2, this is negative 100, and this one is negative 20 by 15. Okay, so this one should be negative 150, I think. All right, so I've got all of those. What do I do with them? No, I divided it by 2, right? Oh, sorry. No, I divided it by 2 twice, didn't I? I did. Silly me. Okay, sorry. So this one would be 100. Sorry, no, this one would be 200. And this one will be 250. Okay, sorry. And they're both negative because they're below the x-axis. All right, so what do I do with those numbers? I add them up, right? Okay, so I got 600, 1,050 on the top. Okay, so 1,050 positive, and then I've got 450 negative, so I shouldn't end up with 600 meters, right? Yeah, okay, so my total displacement here is 600 meters. Okay, is that ringing a bell now that you've seen it done? Okay, because you did a whole bunch of that in Science 10. Okay, all right. It should be 300, yeah. This one shouldn't be 250, it should be 300. 40 times 15, right? Double check it. This is the danger of doing things in my head. Yeah, it should be 300. That's why I don't typically do math in my head, because I'm not good at doing math in my head. So this should be 550 then. All right? Yeah, should be 550, not 600. All right. Everybody okay with that one? Sorry. Because it didn't give us one, I would just say positive. Okay. We can't say north because it didn't specifically say north, but we did have positive and negative on the graph, so that's what we go with. I totally agree with that confounding logic that it also didn't say that it wasn't north, but in the fact that it didn't say it wasn't, also didn't say it was, so it's not.
Oh, okay.
Yeah, we can go on that forever, but we're not going to. Okay.
That way.
All right, that way. Yeah. Okay. I need those quizzes, guys, in a nice neat pile on this desk here, please.